8.2, we're continuing with our sequences in series, but we're getting more specific today and focusing on arithmetic sequences. So in arithmetic sequence, we have a common difference. So it's when you add or subtract to get from one number to the next. So an example of an arithmetic sequence would be like 3, 5, 7, 11, because we add what to get from one number to the next? We add 2. So since we have a common difference, this would be arithmetic. 7, then 9.
Ryan, you could have said it a little nicer.
Yes. I think you can say it either way. Arithmetic. Arithmetic. I don't know. We'll have to look that one up. Okay, so our common difference is what we call D. So the number D is our common difference. So example 1, A, B, and C kind of just show you examples of an arithmetic sequence. So if we had the sequence 4n plus 3, we can determine what our common difference is because it's going to be, remember that slope that we have here, but also if we plug in numbers, so if I plug in 1 for n, if I plug in 2, if I plug in 3, and plug in 4, I can see that my common difference is 4. I'm adding 4 to get from one number to the next. In B, what would be my common difference here? -5. So that means I'm subtracting 5 to get from one number to the next. And in C, what do you think my common difference is? 1/4, because 1/4 is being multiplied to n. So I'm adding 1/4 each time. So the nth term of an arithmetic sequence has the form a sub n is equal to a sub 1, which this will be our first term, plus n minus 1 times d. So n is the term that we're on, so the term number, and then d is our common difference. Bless you. So this is one formula we can use. We also have another one that is a sub n is equal to d times n plus a sub 0. So these are two formulas that we use to find the nth term of an arithmetic sequence. So that expression to help us find whatever term we want. So these are the same thing. They help us find the same thing. So example 2, we want to find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. So since it gives us the first term, we want to use our first formula that we have here. So a sub n is equal to a sub 1 plus n minus 1 times d. So what's a sub 1? 2, because that's our first term. And d is 3. It says the common difference is 3. So we can leave it like this, or we can simplify. So I would distribute that 3. So a sub n is equal to 2 plus 3n minus 3. And then combine like terms. This would be 3n minus 1. All right, so for 3, we're doing the same thing, but it gives us the 4th term of the sequence and the 13th term of the sequence. So we have to come up with the formula given this. So we start with, it gives us a sub 4 which is what? 20. And it gives us a sub 13, which is 65. So to start, we want to figure out how many numbers we have going from 4 to 13. 9. 13 minus 4 is 9. So we have 9 numbers in between. 9 numbers from one to the other. Nine numbers. It's an S. So ideally we want to find out what our common difference is and use that to find what our first term is so we can come up with a formula. So we are given a sub 13. We always start with the larger one. So a sub 13 is going to be equal to a sub 4 plus however many numbers we have from one number to the next. So that's where that 9 comes in handy. Times d, because we're trying to find our common difference. So always start with the larger one, the one that's farther away from 1. We know what a sub 13 is and we know what a sub 4 is, so we want to plug those in. So I have 65 is equal to 20 plus 9d. So then we just solve for d. So what do I need to do first? Minus 20. So 45 is equal to 9d. Divide by 9. So d is equal to 5. So 5 is our common difference. Since we're given a sub 4, we could, if I set up a little table here, my fourth term is 20. So what would I need to do to go backwards to find the third term? Subtract 5. So this would be 15, 10. What would my first term be? 5. So it says write the first several terms of the sequence. So these would be our first several terms. And then I can come up with an equation also. So a sub n is equal to, we can use dn plus a sub 0. We would just have to find out what our a sub 0 is. What would our 0 term be? 0, because we just subtract 5 again to find what our 0 term is. So a sub n is equal to, what's d? 5n.
Why are we doing the green one?
Just to find the equation. So if this question asked me for the 100th term, I have an equation. So it doesn't ask for it. I would just plug in 100 for n. So it doesn't ask for the green equation, but this would be our equation for the system. The answer would be like these terms. Because the question just asks, write the first several terms of the sequence.
Is this B different from last year? You're not the two regular?
No, not different.
Like when I brought up.
We did the same exact thing last year. I think these types of problems are the hardest, where it gives you not your first term, it gives you 2 random terms, but just remember you always set it up this way. So find out how many terms from one to the other, and then use this formula. Start with the larger numbers equal to the smaller one plus however many is in between times d. So this is what you need to know. All right, in example 4, we want to write the formula and find the 54th term. So our formula that we can use is, we can use the one that has a sub 1 or a sub 0. I think the a sub 0 one's a little bit easier, I guess. So a sub n is equal to dn plus a sub 0. First thing I want to do is find my common difference. I need to find what d is. So what am I adding to get from one number to the next? 7. So d is 7. So what would my a sub 0 term be? If I go backwards, that means I have to subtract 7. So 2 minus 7 would be negative 5. So my 0 term is -5. So my equation would be a sub n is equal to d, which is 7, times n, plus a sub 0, which is -5, so -5. Now this question asks for the 54th term. So how do I figure out what the 54th term is? Plug in 54 for n. So I have a sub 54 is equal to 7 times 54 minus 5. So this would be 373. So we could sit here all day and keep adding 7 again and again and again until we get to the 54th number. But it's going to be a lot easier just to come up with the formula and plug in 54. And there's a lot less room for error this way too. All right, last thing we're going to look at today is the sum of a finite series. So to find the sum of a finite series, we use this formula here, where n is the number of terms, a sub 1 is the first term, and a sub n is the last term. What does it mean to be finite? It has an ending. So let's look at number 5. We could sit here and add 1 plus 3 plus 5 plus 7 plus 9 plus 11. But when you get to a whole bunch of terms, it's going to take a long time, and you won't have time for that on the test. So we use this formula. S sub n is equal to, how many terms do I have here? 10 terms. So n is 10, because I have 10 terms. So 10 divided by 2 times, what's our first term? 1. And what's the last term? 19. So S sub 10, the total of our 10 terms here, would be 5 times 20, which is 100. So if I were to add all of these up in my calculator, I'd get 100. So example 6 says find a partial sum of an arithmetic sequence. We have to find the 150th partial sum of the arithmetic sequence here. So to find my partial sum, my formula is S sub n is equal to n divided by 2 times a sub 1 plus a sub n. Do I know what the first term is? Yes, a sub 1 is 5. Do I know what n is? It's 150 because it's asking me to find the 150th partial sum. So n is 150. Do I know what a sub n is? No, I'm looking for my 150th term. I don't know what that is. So how do you think I can find the 150th term? I have to figure out what my equation for this sequence is. So what am I doing to go from one number to the next? Adding 9. So my formula is a sub n is equal to dn plus a sub 0. We're adding 11. Good job, Gio. I trusted you. It's okay. So D is 11. How do I find what the 0th term is? Subtract 11 from 5. So since we're going backwards, we subtract 11. So that would give us -6 for our a sub 0. So I have 11n minus 6. So then I plug in 150 because it's asking me to find the 150th term. So a sub 150 is equal to 11 times 150 minus 6. What do I get when I subtract 6? 1,644. That's my 150th term. So now that I know what a sub 150 is, I plug it in. So my sum of the 150 first terms is equal to, what's n? 150 over 2 times my first term plus the last term. So 75 times 1651 or 1649. What do I get?
12, 36, and 5.
So this would be the sum of our 150 terms. So it'd be a lot more work to have to figure out what all 150 terms are, then add them all up together. So you would have to use the formula here. Any questions? All right, the web assign from 8.1 and 8.2 are due tomorrow, so you guys can use the rest of class to work on those.